So let's see. Let's go ahead and let's, as an example, just to see what's happening here. So graph in the same coordinate system, in other words, in the same xy plane, the same coordinate system, the following functions. The function f of x equals x squared. Then let's graph the function g of x equals 1/2 x squared. And then let's graph the function h of x equals 2 times x squared. Let's see what happens, okay? So again, what I'm hinting at here is that when you multiply a function by a number, then two things could happen. Either this number is greater than 1 or less than 1. I mean, if it's equal to 1, you're not doing anything. And if it's negative, we know the negative part what it does. It's a reflection, okay? So let's just focus on positive stuff. So if the number is bigger than 1, whatever we see, we observe in the blue situation, that's the general thing that's going to happen. If the number is between 0 and 1, this is an example, right? This is a 0.5. Then whatever happens in the red picture, that's the general thing that's going to happen, okay? So let's see. So here it's convenient to do a bigger scale. So let's declare that this is 1 over here. And if this is 1, then this is 2. And this is 3. 4 is over here. Okay. So 1. Just gonna go to 2. All right, so let's work with this scale. All right, so let's do it. So for this one, we know what it is. So it's 0, 0, 1, 1, negative 1, 1. And then let's do 2, 4. And then negative 2, 4. Something like that. Okay, so this is a function f. Now, let's think about g. So what do you think is happening to g? So we're taking x squared, right? So we're taking the x squared, which are the y values of the function f. Everybody understand this? And then what are we doing to those y values? So we are multiplying by 1/2, which means dividing those values by 2. Yes? So are they getting bigger or smaller? They're getting smaller. In other words, for the same x, for example, this one right here stays there. But how about this one? When x is equal to 1, f has y equals 1. What will be the corresponding y value for g? 1/2. So that guy is going to go down here. 1/2. Okay? For example, when x is equal to 2, f has y equals 4. What will be the corresponding y for g? 2, right? So it's going to go here. And then, same thing over here. And then over here. So what's happening is that we're taking this picture and we are not affecting the x values, but the y values, we are cutting those by 1/2. So we are dividing those values by 2. In other words, we are making this picture get closer to the x-axis. Do you understand this? So if you sketch, we get this sort of shape. So it's a shape that's closer to the x-axis. Do you understand this? So when this happens, we call this a shrink of the graph. Okay? So we call this a vertical shrink of the graph because it's going towards the x-axis. It's like if you push it down to make it closer to the x-axis. Without, imagine that you're not allowed, this one is not allowed to move, and then you're pushing the graph down. Okay? That's what's happening. So the bigger is the number that we're just dividing, the closer this is going to be to the x-axis. Like if I divide this by 1,000, is gonna be super, it's gonna be like something like, I mean, even more than that, but it's gonna be like very, very close to the x-axis. Do you understand what I'm saying? Okay. All right. So what happened from here to here was, so this is a function g, and what's happening from here to here is a shrink. Okay. Now let's analyze the function h. On the other side of the spectrum, what is it that we're doing? When we look at h, this is the y of f, x squared, and what are we doing to the y of f? We're doubling this quantity, right? So we're multiplying it by 2. So what does that do to our function? What does it do? So technically, it should make, well, not technically, that's always the case. So what we're doing is we are increasing, the y value by 2. So we're doubling, we're doubling the y value. So we are multiplying it by 2. So what happens is we're going to have a stretch because now our graph is going to get closer to the y-axis. Before it was getting closer to the x-axis, so that's what we call a shrink. And now it's going to get close to the y-axis, so that's what we call a stretch. Because now when x equals 1, we're going to be up here at 2. And well, when x equals 2, we're going to be all the way up to 8. And I'm going to draw that. Okay? So I'm going to have this sort of picture now. Okay? This is h. So h is closer to the y-axis than f. Do you understand this? So it's like, imagine that this point doesn't move, then you take the graph and you stretch it. If you stretch it, imagine that this is made out of rubber band or something, and you put a stone here or your feet so you can now move it. What happens if you stretch it? It will get close to you. If you don't do this, if you just stretch it up, what's going to happen is that the check is going to get closer to your leg or whatever it is that your axis is that is holding the ball. Okay? Anyways, we call that a vertical stretch. So what happened from here to here was a stretch. Do you understand this? So multiplying by a number makes the graph either shrink or stretch, vertical. How? How do you know which one is it? Well, if the number is bigger than 1, you get a stretch because you're making the y's bigger. If the number is less than 1, between 0 and 1, then the graph is shrinking. Do you understand this? If you multiply by a negative number, what's happening? What does it mean if you multiply by a negative number? Those are two transformations. The negative is your reflection about the x, and then the number is the stretch or compression. For example, if you multiply, if you have negative 2 times x squared, that would be the x squared function. You reflect it, and then you stretch it. Which in this case, you stretch it down. Do you understand this? Or you could stretch it up and then reflect. That's okay. Reflection and stretches, you can interchange them and then do them whichever you want first. Okay? The thing that you should not do is move around before you take care of any stretch or reflections or shrinking or that show off. Okay? All right. Questions? No questions? Okay. Yes. Let me tell you why. I kind of told you why we don't want to move before we do any reflections. Let me tell you why we don't want to move if there is any stretch happening. So let's say that you move first. Okay. So let's say that you are here. Let's say this is a 3, right? So this is the function y equal x squared plus 3. And let's say that you want to stretch this by a factor of 2. But let's say we want to treat this by a factor of 3. So that means I want to multiply this by 1/3. Yes? So let's say that I want to treat this by a factor of 3. What's going to happen? What will be the resulting graph? Will it be something like this? Will it be something like this? The answer is no. If you treat by a factor of 3, what's going to happen is you have to multiply the function by 1/3. So when you multiply the function by 1/3, this guy becomes a 1. So now your graph also moves down here. It opens up, but it also moves down here to 1. You see? And why is this movement happening? Well, because the y-intercept is no longer at 0, 0. Now y-intercept is 3. So when you multiply it by 1/3, it's going to become a 1. Understand this? Now here, because we were already at the origin, the y-intercept is 0. You multiply it by 1/3, it's still 0. So your picture doesn't move, doesn't get out of place. You just push it or pull it, whatever you need to do, shrink or stretch. In this case, it's shrinking. Shrink or stretch, but the picture doesn't move. But if you are away from the original position, like in this case, and then you want to do your shrinking, it will move. So you have to be careful. That's why it's not recommended to move around and then do reflections and stretches. So you start in the original position that typically is around the origin, right? The picture usually starts touching the x-axis anyways. Okay? And then you do any deflection and stretching and compression that you have, and then you start moving right and left, up and down. Okay? Otherwise, it could be a little bit uncomfortable. I mean, you can do it, but it will be hard. All right, so let me write it down and then do our examples. So stretches and shrinking. So stretching and shrinking. Shrinking, sometimes we also call it compression, okay? It could be also compressing the graph. All right, so the first statement is number 1. So y equals c times f of x, where c is a number bigger than 1. This is a vertical stretch. This is a vertical stretch of the graph of f by a factor of c. Okay, so it's a vertical stretch of a graph of f by a factor of c. So let me explain a little bit more what I mean by this. So i.e. the y values of the points on the graph of f are multiplied by c. Okay, that's what I mean when I say by a factor of c. That means the y value get multiplied by that c. Okay, so you have 2 times something, then if you have the point 2,3 on the graph, then that point becomes 2,6 because the 3 has to be multiplied times 2. Okay, so the y values of the points on f are multiplied by c. And then similarly, if instead you multiply the function by a number that is between 1 and 0, okay, so if y is c times f, where c is between 0 and 1, this is going to be a vertical shrink or compression. It's a vertical shrink or compression of the graph of f. By a factor of c. And again, because I'm already saying, let's see, really, we should say by a factor of it's gonna look weird, but of 1 over c. When you're speaking, you don't say I'm shrinking by a factor of 1/2. What you say is I'm shrinking by a factor of 2. Because we're using the word shrinking, it means that we're compressing, so it's understood that this means multiplied by a half. So you have to flip the number. Okay? So here, because the number is between 0 and 1, my c is 1/2, so the factor by which we're shrinking is by a factor of 2. Do you understand what I'm saying? Yes? So for example, if you you want to express as an equation, let's say X represents the amount of money that you have, and you have to pay somebody $1,000. How do you represent the balance in the balance of your money? X minus 1,000, right? But when you use language, do you say I pay negative $1,000? No, you say I pay $1,000. The word pay is the one that says put a minus in your balance. If you say I earn $1,000, the word earn puts a plus in your balance. Do you understand what I'm saying? So here, the word stretching, it assumes that you're multiplying already by something bigger than 1. If you say shrinking, then that makes 1 over whatever the factor is. Okay? It's just a matter of language. So it's a vertical shrink of the graph of f by a factor of 1 over c. So i.e. This also means that the y values, because c is already between 0 and 1, really it doesn't change what you do. So the y values of the points on f are multiplied by c, or if you want, multiplied by c. So in other words, you have to be careful because it always means the same thing. You always multiply by c. It's just that when we use language, in this situation, we flip the number because you're already saying the word shrinking. Okay? So saying shrinking by a half is a little bit weird. You shrink by a factor of something. You shrink by a factor of 2 because you're shrinking. Means you're half. Okay. Anyways, the point is that you multiply the y values by whatever number you have. That's the bottom line. All right, so let's do examples. So sketch, and let's do f of x equals, let's see, I want to make sure that I have time. So I'm going to do this one quick, okay? So let's do this one. And then finally, let's throw in a bunch of things together. And I could throw in a negative thing here, and that way we have all the transformations in one problem, but let's not delay that too much. All right, so let's see. Let's first look at this, and let's practice this. Tell me how many transformations are happening and what are they. So let's look at the first one. So first parent function. What's the parent function? How many transformations are we doing? What are they? Deflection across the x-axis.
Vertical stretch.
By a factor of 2.
And then 3 up.
And then move it up 3 units. So in your mind, you should already create a picture for this, right? It's a parabola that's pointing down, that looks like this, with 0 somewhere down here and up at 3. Okay? So if you got it in a hurry, you can probably sketch this in one shot. Okay? All right. How about this one? What's the parent function? Square root. How many transformations are we doing?
4.
So let's see, we're doing 1, 2, 3, 4. Good. What are they?
Vertical stretch by a factor of 4.
Okay.
4 is not, reflection across the y.
Okay.
1 to the left. 1 to the right.
Okay. Good. Be careful.
3 down.
And then 3 down. Good. Now, this one, to see more clearly, remember, there is a little thing that we should do here. We should factor out the negative just to see the one to the right more clearly. Good. I'm pretty sure the minus here, that would. I'm going to change it, put a minus here, because this is similar to the example that we did above. So let me put a minus here, this way we go left instead of going right. Okay? So, let me put a minus here. That way we go left instead of going right. Okay, let's do it. So solution, the first one, we have this, so we already have our plan. So we start with the basic function, then we're gonna flip it, then we're gonna stretch it, or you could do it the other way. You stretch it first and then you flip it, it's up to you. Okay, and then finally, we shift it up. mean, you don't really need to write the words. I mean, I'm gonna write it, but if you don't really need to sort of reflect about x, then here stretch by a factor of 2, and then from 3 to 4 it goes up 3 units. Okay. So start with a basic graph, which is y equal x squared. Here it's very important. It's very important to have your key points. Okay. We have our 3 points. Now, what are we doing? We're reflecting. So it's going to go down. 0, 0 stays there. Then 1, -1, and -1, -1. Okay. So we reflected. Now we're going to stretch it. So we're going to pull this down by a factor of 2. So that just means take the y value multiplied by 2. Okay. That's all it means. So 0, 0 stays there because 0 times 0, 0 times 2 is just 0. But now 1, -2, the 1 stays there, but the -2, you need to multiply by 2, so it goes down. The -1 multiplied by 2, so that will give you -2. Same thing for the other. Okay. So we pull it down by a factor of 2, and now we need to take this picture, shift it up 3 units. So let's see, 0, 0 is going to go up to 3. Then 1, -2 is going to go up to 1, 1. And then -1, -2 is going to go up to -1, 1. So we get this sort of picture. And now again, 2 interesting points showed up. We need to find them. Those are the x-intercepts. To find the x-intercept, we need to solve this equation. Set the function equal to 0. That's a little quadratic equation. So we get x squared is going to be 3/2. So x is plus or minus square root of 3/2. Okay. So this guy here is positive square root of 3/2. And this one over here is negative square root of 3/2. Okay. All right. Questions? Any questions?